Welcome everyone. In this video lecture, we will solve a GATE 2025 EC question in which we have to determine the small signal voltage gain V0 by Vs. So a figure is given. So the question is a simplified a small signal equivalent circuit of a BJT based amplifier is given below. So a small signal equivalent model of a BJT is given here. So this one is our, we can say, base side. This one we can say the emitter part, and this one is our collector. Okay, so this one is the circuitry given. We have to find V naught by Vs. Okay, V naught by Vs we have to find. So this one is a very simple problem. So first what we will do, this current is our, we can say, the collector current IC, and this current is flowing like this. Okay, this current is flowing like this, and this current is nothing but simply we can say IC, or IC is nothing but simply I, small c is nothing but simply beta IB. Okay, this one is our IC or beta IB we can say. So this one is some resistor, okay, and this is RL, and this one is V naught, and we are saying this current is nothing but simply IC, or this IC equals to beta times of IB. Okay, so one can write this one, because this potential is 0, V naught, so we have to find IC. So this value can be written as, because current is flowing from this side, so this will be considered as a higher potential, so we can write it 0 minus V naught by RL. Okay, so it will give V naught equals to minus beta IB RL. One can also directly write V naught equals to this current into this RL, but this one is going like this, and this one is plus of minus V naught. Okay, so V naught is directly we can write minus beta IB RL. Okay, you can directly write, or this is the way we have to write. This is RL, so some voltage is there. This one is considered as a higher potential voltage, lower. So IC equals to beta IB, and this one is nothing but simply 0 higher potential minus lower potential, we can say minus V0, because current is flowing like this by RL. So V naught we can directly write minus beta IB RL. Okay, so this one is the output voltage V naught. Now we have to find the, what is the value of this Vs. Okay, so for this purpose what we will do, we will simply apply Kirchhoff's voltage law. Okay, I'm just, we will use some Kirchhoff's voltage law in this section. KVL in this loop 1. If we apply KVL in loop 1, okay, so I'm writing here, by applying KVL in loop 1. Okay, so what we will write, so it will start from this one is nothing but simply plus or minus Vs. Okay, so one can write this as a plus Vs minus IBRS, because this one, this current is IB current, so one can write minus IBRS. Okay, and this current is going like minus IB R5, and it should be 0. Simple Kirchhoff's voltage law. So from here what we can write, Vs equals to IB, take common IB, RS plus R pi. So one can write IB value directly Vs by Rs plus R pi. Okay, say this one is our equation number 1, and I am saying this is our equation number 2. So from 2 we have derived the value of IB. Okay, now we have to find V naught by Vs. So if we put the value of IB as a function of Vs, we will get the V naught by Vs. Okay, So what we will do, as we know, V naught is given. V naught is minus beta, okay, right, minus beta IB by RL. Now we will put the value of IB here. So what we can write, minus beta IB Vs by Rs plus R pi into this RL. Okay, this one is V naught. What we are doing, we are just directly putting the value of IB. Okay, directly putting the value of IB. This IB. Okay, IB. This one is IB. We are directly putting here. So finally, what we will get, V naught by Vs we have to find. So V naught by Vs minus beta RL by Rs plus R pi. Okay, so this one is the result that we are looking for. V naught by Vs, the gain. Okay, so V naught by Vs is simply our minus beta RL by Rs plus R pi. So which one is the correct answer? We can say this one is the correct answer. Okay, or we can directly say this one. Okay, this one is the correct answer. Okay, so this is all about this simple question, simple fundamental question. Means we have to find V naught by Vs. So V naught we are finding this current I into R. Okay, but current is going from this direction. So minus beta IB RL, because current is flowing from zero potential. So minus IB beta IB RL. Now for input section, we just apply Kirchhoff's voltage law. Vs minus IB RS minus IB R pi. Okay, equals to 0. Then IB we have find. Then IB we know. Then we know is as a function of IB. Then we are putting the value of IB, and we are getting this result. So this is all about a simple, very simple question based on a small signal voltage calculation of a BJT. So this is all about this question. So thank you for watching this video. Thank you.